Section 5 of our vector notes, we are going to take the polar form of this vector and convert it to component form. We did this before, but before we had special right triangles every time, and in this time we will not have special right triangles. So first of all, this is going to be in quadrant 1, it's 20 degrees, and the length of our vector is 5. So it might look something like this. To figure out the x and y components of this, we're going to have to use trig. Make a reference triangle. Now when we do this, well, I'll show you and then I will give you the short version of this. To figure out the x component, we're going to use cosine. Cosine of 20 degrees is the adjacent leg over the hypotenuse. It's x over r. That's going to make x 5 times cosine of 20 degrees. Keep in mind that r, which is the radius, is 5. We're also saying that's the magnitude of this. So what I am telling you is, if you want to find vector v in component form, the first component is going to be r times cosine of theta, because that's what we have here. We have r times cosine of theta. Put this into our calculator. 5 times cosine of 20 degrees. We're going to get about 4.7. We will round to 1 decimal place. To find the y component of this, we would do sine of 20 degrees is the opposite leg over hypotenuse. Sine in the coordinate plane is y over r, using a reference angle. Therefore, y is going to be 5 times sine of 20 degrees. If you want to find the y component of your vector, you're going to take the radius times sine of your reference angle. 5 sine of 20, that is 1.7 approximately. So to sum up, if you're given vector with a direction of 20 degrees and a magnitude of 5, which would be here, you could find that same location by using the x and y components, which is right 4.7 and up 1.7. Also, a sum up, to find a vector in component form, given its magnitude and its direction, you take r times cosine of theta for the x value and r sine of theta for the y value. Number 2. So before we even get into the picture, let's just write down in component form, this is going to be r cosine of theta followed by r sine of theta. Which means, like if you just want to straight up, if you just know this formula, we don't have to do much as far as the picture goes. R is 3, and the angle is 80 degrees. R is 3, and the angle is 80 degrees. I will draw a picture before we're done, just to make sure we understand what's happening. 3 cosine of 80 is 2.9, repeating. Well, it's super close to 3. If we round this to 1 decimal place, that will be super misleading. Because it's going to look like it's just 3, which it clearly isn't. Oh, I understand what I did wrong. When I put that degree symbol, it misinterpreted that as an exponent. My apologies. So that would make this 0.5. I was freaking out there for a second. And then 3 times sine of 80, that would be 2.95, which is super close to 3. Too close to write 3.0. So picture-wise, what would this be? If you needed a picture for this, this is in quadrant 1. Magnitude is 3. The angle is 80 degrees. This is y, this is x. You could go ahead and you could say, well, sine of 80 degrees is y over r. Cosine of 80 degrees is x over r. And they're both going to lead you to this right here. Number 3, this is going to fall into quadrant 3. Now, once again, we could just drop directly into this and say, well, the component form of this is going to be r cosine of 230 followed by r sine of 230. I jumped in there too soon there. R cosine of theta followed by r sine of theta, which would be 5 cosine of 230, 5 sine of 230. We'll see what happens if we throw this in our calculator, then we'll finish the picture and try to make sense of it. So 5 times cosine of 230 should be negative. I keep writing a degree symbol, my apologies. Negative 3.2. If we do 5 sine of 230, we get negative 3.8. If you don't like just using the formula, that's cool. You draw this picture. We have, this is 5. That's 230 degrees. It makes the reference angle 50 degrees. And we don't know x and we don't know y. Now, when you figure this out using the 50 degrees, like if you do cosine of 50 degrees is x over 5, it's going to give you a positive answer because this is saying it's in quadrant 1. So you have to know when you're finished to change the sign of this. And if you do the same thing for sine of 50 degrees to fill out this triangle, it's also going to give you a positive answer. And you have to know that when you're in quadrant 3, it has to be negative. So if you needed to do more work, go for it. If you just want to use this, that's fine too. It's probably what I'm going to be doing. Number 4, let's just go right to it in component form. It's r cosine of theta followed by r sine of theta. X, y. Remember, cosine is x over r, sine is y over r. So that's 4 cosine of 320 degrees. And this is 4 sine of 320 degrees. This should be positive and this should be negative because this puts us in quadrant 4. Four cosine of 320 degrees. That's about 3.1. 4 times sine of 320 degrees is negative 2.6 approximately. That's negative like we suspected. All right, that wraps her up.